Hello everyone, let's solve a problem from GATE 2013 Aerospace Engineering paper, question number 29. The question is, a function y of t satisfies the differential equation d square y by dx is dt square minus dy by dt plus y is equal to 0 and is subjected to initial conditions y of t is equal to 0 is 0 and dy by dt of t is equal to 0 is 1. So the value of y at t is equal to 1 is dash. We have been given four options e, 0, 1 and minus 1, right? So we have been given a ordinary differential equation which is homogeneous. We have been given two initial conditions and we need to find the value of y at particular time which is at 1, right? Let's go and solve the problem. D square y by dt square minus 2 dy by dt plus 1 is equal to 0. First we will find the roots. So for that we have to replace d by dt by d. Then we will get d square y minus 2 dy plus y is equal to 0. So if we just take y outside, then we will get 2d square plus 2d plus 1 is equal to 0. So which will give us d minus 1 is equal to 0. Then our d becomes 1 comma 1. So these are real and repeated roots. So then our equation will be of the form ax plus b e power alpha x. This alpha is our real and repeated root. Here our alpha is 1, right? Then our solution will be ax plus b e power x, right? Now let's substitute our first initial condition, that is okay, so everything will be in t. Since we have our function y as a function of t, right? So the y of t is equal to 0 is equal to 0. Then we will get 0 is equal to a into 0 plus b into e power 0. So this gives us b is equal to 0. Then that will change our y to be a t e power t. Okay. Then our second boundary condition is, the initial condition is y dash of t is equal to 0 is equal to 1. First we have to find y dash. So if we find, so we have two functions of t which is in the product. So we have to use the product rule. Then first we will keep our first function and differentiate the second function. Then we will keep the second function and differentiate the first function. Okay. Then we will get, if we take e power t outside, then we will get t plus 1. Now let's use our second initial condition. Y dash of t is equal to 0 is 1, right? So y dash is 1, a e power 0, t is 0 plus 1. So then we get a is equal to 1. Then our function becomes t e power t. Okay. Now we have to find y of t is equal to 1. Okay. Then what becomes 1 e power 1, which is e. Okay. Then our final answer y of t is equal to 1 is e. So let's go to the options and see whether we have the option e. So as you can just see, option A has the correct answer, which is E. So that's the right answer, right? So if you want to know more about similar concepts, you can refer to the NPTEL course Engineering Mathematics 1 by Professor Jitendra Kumar from IIT Kharagpur. And the particular lecture for this question is lecture 57, which is solution of higher order homogeneous linear equations. You can also see the YouTube link for the particular lecture here. Okay, that's all for this question. Thank you.